Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to Wisdom International School's digital classroom for mathematics. Children, we had started with exercise 5.1 in the previous session in introduction to graphs, right? So there are a few more problems in this exercise which I wanted to go through with you people. So come to this question number 5. So here you are supposed to draw the graph. Okay, so I'm going to show you how to draw the graph. So this question you are supposed to, these questions, like drawing the graph and all, you have to do it in your graph notebook only. Okay, so here look at this. It says use the tables below to draw linear graph. Okay, that is the line graph. Linear graph in the sense the line graph. Okay, so the number of days a hillside city received snow in different years, and then the year and days are given: year 2003, 2004, 2005, 2006. Okay, and then on the days it's given as 8, 10, 5, 12, etc. All right, so now you see, you take the graph. Okay, so I'm going to draw the x-axis, y-axis. All right, so let me draw the x-axis and y-axis. This is the y-axis. Okay, and okay, and this is the x-axis. All right, so now I am going to mark it. Okay, so it's 2003, 2004, 2005 and 2006. So let us mark. So let's say this is 2003. Okay, 2003, or you can mark, yeah, so I can mark it in a double this thing also. Wait a minute. So let me take 2, 2. Okay, so this I will take it as 2003. Okay, and then this, after 2 coordinates, I take it as 2004. This is 2005, and this is 2006. Okay, yeah. So now I have to mark the y-axis. So this is year. In the x-axis I have to mention that it is year. Alright, now, and the y-axis, okay, what do? I have to write days. Okay, so 8 to, see, the smallest is 5 and the largest is 12, right? So let me take it as, like, 2, 4, 6, 8, 10 and 12. Okay, so let us just mark it. 2003 is 8, so mark 2003 8 over here, and 2004 is 10, so 2004 10 over here. 2005 is 5, 2005 is 5. Okay, so over here. Okay, and then comes the next one, 2006. What is 2006? 12. Okay, so 2006 is 12, so let's mark 12 over here. Yeah, so now you will join this. Okay, it's like this, then like this, and then like this. This is the linear graph. Okay, yeah. So now come to the next question. So population of men and women in a village in different years. So here 2 graphs are supposed to be drawn. I mean 2 line graphs. You have to draw it. Okay, so let me just first draw the x-axis and y-axis. So let's just draw the x-axis, y-axis first. Let me say this is my y-axis. Okay, and this is the x-axis. Alright, yeah. So on the x-axis, what am I supposed to write? I have to write year. Okay, this is year. And on the y-axis I have to write both, number of people. Okay, men and women both. All right, so number of men or women, so number of people. Okay, so now here let's mark the coordinates first. So year is 2003 to 2007. So as usual I can take double things. So 2003 2003, 2004, 2005, 2006, and this one is 2007. Okay, now I have to mark the y-axis. So y-axis is like, you see the range is like 12, 12.5, 13, 13.2, 11, and the smallest is 11, right? 11.3, and the largest is actually 13.6, right? So it has to be between 11 and 13.6. So what can I do? I'll just write, if I write 11, let us say I take 11. So this is, let us say, 11. Okay, and this, okay, wait a minute. So I can take this as 11 and then double, this will be 12 and this will be 13. Okay, and if you want, you can take this as 14. Yeah. Okay, so now let us start marking it. Okay, so first you have to mark it, like, let me say, I just say that the straight line the green line, or let us say the blue line goes for men. Okay, so blue line is men, so I'm writing men. Okay, and then the pink line is for women. All right, so I have to be careful with this, like, okay, so like women. So now first let's draw the men, or let's draw the women first. So number of women in 2003 is 11.3. So 11 point, so double you have to take it. Okay, so 11.3 is going to be somewhere over here. Okay, and 11.1, 11.5, 11.3 over here. Okay, 11.1, 11.2, 11.3 is somewhere over here. Okay, because this is 11.5, right? So this is 11.3. Okay, then comes the next one. In 2004 it's 11.9, so 11.9 is close to this over here. Okay, and then comes 2005 is 13, so you can mark 13 over here. Okay, and then in 2006 you have to mark 13.6, so 13.6 is going to be 13.5 over here, and you have got the next one as 12.8. So 2007, 12.8 is over here, 5 and 8 is over here. Okay, so now you join the graph, so you just draw the line, straight line. Okay, and then like this. This is your women. Okay, now for men, let's use the blue color. Okay, so the number of men is 12 first here, and then comes your 12.5. So your 12.5 is somewhere over here, and then next is 13. So you mark 13 over here, and then you mark 13.2. So 13.2 is somewhere over here, and then you have 13.5. So 13.5 is over here. Okay, so now this is how it is. So it's almost straight line. Okay, all right. So now we'll so based on this, if you have any answers, you just answer it, or you just you can move on to the next question. Okay, so here it says a courier person cycles from a town to a neighboring suburban area to deliver a parcel to a merchant. His distance from the town at different times is shown by the following graph. So now you see what is the scale taken for the time axis. So in the time axis, what have they taken? It's the x-axis, right? So 8 a.m., 9 a.m., 10 a.m. So everything is like 1 hour, right? So 1 hour is the scale taken. How much time did the person take for the travel? So how much time has he taken? From 8 a.m. he has gone till 11:30, right? This is 11:30, right? So how much? So 1 hour, 2 hour, 3 hour, 3.5 an hour. 3.5 an hour, or you can say 3 hour 30 minutes. Okay, how far is the place of the merchant from the town? So this is the distance. When they say how far, they're talking about the distance. How much is the distance? So from here to here, what is it? 22 kilometers. This is kilometers, right? So it's 22 kilometers. Okay. Did the person stop on his way? So explain. So when is he stopping? So you have to see the graph carefully. See, this graph is moving, right? It's going on. So that means this man is moving. Then after that, as time passes, this distance is also moving, right? So this man is moving here also. Now here, from here to here, you see, as the time passes, okay, from 10 to 10:30 a.m., the distance remains as 16. That means he has not moved anywhere. So he has stopped. So this is the place where he has stopped. Okay, so that you have to explain it. Yeah. So from 10 to 10:30 he has stopped. 10 to 10:30 he has stopped. All right. Then during which period did he ride fast? So when was the line increasing? See, increasing means, see, this is increasing much more the faster rate. Now if I do this way, this is slow increase. Okay, so this is more increase. You look at this, from 10 to 2. So this is 6 kilometers he has gone. In 1 hour, 8 to 9 a.m. he has travelled 6 kilometers, right? 10 kilometers, right? Okay, I'll just choose a different pen. So he has used 10 kilometers. He has gone 10 kilometers. Okay. From 9 to 10, how much has he gone? 16 to 10. So that is only 6 kilometers. Okay. And then 11 to 12, 11 to 11:30, it is 22 to 16, right? So 22 to 16 is 6 kilometers again, right? So each hour this thing is being given. So the first hour is where he is traveling really fast. Okay. So during which period? 8 to 9, 8 a.m. to 9 a.m. Okay. This is when he has travelled fast. Okay. Now, can there be a time temperature graph as shown? Just justify your answer. So they are saying that, is these graphs possible or not? Now you should see there is a time in the x-axis and temperature in the y-axis. Okay. So as time increases, temperature is increasing. Is this possible? Yes, it does. It is possible, right? See, if you're let us say you're heating something in a stove. Okay, as time increases, the temperature increases, right? The water, let it be the water or anything, it slowly, the temperature increases as time goes. So this is a possible case. Okay. Then as time increases, the temperature decreases. Is it possible? That is also possible, right? You can keep it in your fridge or something. Keep something in your fridge. Slowly the time increases. Temperature decreases, right? As time goes on, the chillness increases, right? That means the temperature is going down and down. So this is also a possibility. Then come to this one, the third one. As time increases, temperature is time is not increasing, just the temperature is increasing. Is it possible? See, there is no time. See, what does this mean? At this particular time, you have for this temperature also, this temperature also, this temperature also. It's not possible, right? You can have only one temperature at a particular time. How can you have different temperatures at a particular time, right? If you are keeping one object and that object has a temperature at a particular time, as time goes, it will either increase or decrease, or it will remain same. But it can't have different temperatures at the same time, for a single object. So this is not possible. Okay. For the fourth one, it is possible. See, it means that the temperature is same. You keep something in a room temperature, keep a water in the room on your table. What happens? The water remains as the same temperature, right? It's not going to cool or become hot. It's going to stay as what it is, whatever it is, right? So that is a possibility. So as time goes on, the temperature remains same. So that is, you maintain the temperature. So this is also a possibility. Only third one is not possible. So you complete this exercise 5.1 in graph notebook, whichever, because you have few graphs which you have to draw it on the graph notebook and solve the problems. Okay. So complete it. So I'll see you with the next video in the next session. Allah Hafiz. Thank you.